Hi, everybody. It's Professor Ken. As you can see, I've been doing some baking. All right, today I'm going to teach you what you need to know about domain and range for our calculus course. And it's not that hard. And the video won't be too long. However, it should take you about 90 minutes to get through it because during the video, I want you to stop, take notes, practice, etc. So that's how we use instructional videos. So have the pause button ready because there can be plenty of times where you should pause, as I said before, to practice, take notes, etc. Okay, so I'm going to share my screen. And I'm going to turn off the video so my head doesn't get in your way. And for this presentation, I'm going to be toggling back and forth between Desmos and PowerPoint. All right, so this is for today's class, January 30th. Look at this. What we have here is some Desmos art, and you are also going to be doing some Desmos art. So let's take a look at some of these graphs. All right, let's look at this one first. Okay, what we have here is, this is called a coordinate graph because the highest power is 4. And it's got a, we can see that it doesn't go on forever, although we would think that it should. But the reason why is because I said that the smallest x value is going to be negative 2.3, and the biggest x value is going to be 2.3. So if we put a, I'm sorry, let's call this, watch this. If we call this f of x, and we call this point A f of A. Okay. Close this out, close this out. Okay. We're going to add a point and we're going to open parentheses. We're going to say A comma f of A. And this is just like saying XY. If we add a slider, we see that the point is on the graph and we can actually move this around. And it'll tell us the A value. And if we ask for the f of A value, it will tell us that as well down here. All right, now here's why I'm doing this, because we want to find out what the smallest x value is. And we could see that it should be negative 2.3. And I just want to make sure. Okay, that we can see that the smallest x value here is negative 2.3. And what's our biggest x value? It go along like a roller coaster. And we can see our biggest x value on the graph is positive 2.3. All right, so we would say that the domain, is from smallest x value is negative 2.3. The biggest x value is positive 2.3. So we would say for the domain, x is the interval from negative 2.3 to 2.3 inclusive. The reason why it's inclusive is because we have less than or equal to here and here. So let's find out our range. Range are the y value. So our biggest y value is up here. We could see the biggest y value is 5.125. And our smallest y value is not here, although it looks like it could be, but it's what's going on at negative 2.3 and positive 2.3. So our smallest y value is 1.233. So we would say the range of this function is from 1.233 to 5.125 inclusive. Now, how do we write this in calculus? All right, so let's go back to our meeting here in Zoom. Oh, if we stop our share for a moment and we go to our whiteboard. pencil here. Okay, we could say that our domain is from negative 2.3 to. Well, I'm not sharing. Crap. All right, let me share the screen. Sharing your screen will close the whiteboard for everyone. Do you want to continue? I guess I am sharing. I'm not sure if I'm sharing or not. Okay, now I am definitely sharing. So let's go back to our whiteboard. Or maybe I could just annotate. Yes, let's just annotate here. That'll be better. All right, so we would say that the domain, that's a D. We could put a colon. We put a bracket, negative 2.3. Sorry about that. My phone is being to 2.3 inclusive. So we close the bracket. All right. And then for our range, these are our Y values. So our smallest Y value was right over here, 1.233, I believe it was. Let me stop the drawing for a second. Let's go over here. So when A is 2.3, okay, we can see that our smallest Y value is 1.23. We'll just call it 1.23. And our biggest Y value is up here. At 5.12. I just want to make sure it doesn't get bigger than that. .12. So 1.23 to 5.12. So if we go to our annotate again, it's 1.23 or 5.12. Close the bracket. Inclusive. Okay, why don't you take a pause and you practice that. Okay, I'm going to stop my share for a second. I'm going to share once again, and I just have to do that to get back to my PowerPoint. Okay, let's try another one. Let's try this graph right here. Oh, has a square root in it. So what this says here is that f of x equals the square root of x minus 3 plus 2. Now, we can never have a negative under an even radical. And because this is square root, the index is 2. So that makes it an even radical. So we have to say that x minus 3 has got to be greater than or equal to 0. Add 3 to both sides, and we see that x has got to be greater than or equal to 3. And look at that. Let's see what this beginning point is. So if I turn off my annotation and add the point, well, let's just say that f of 3, let's find out what f of 3 is. 3, not f of x. It says f of 3 equals 2. So that's this point right here, just what we would expect. So the smallest x value is 3, which also means the smallest y value is 2. And it goes up to infinity. So how do we write this? Go to annotate again. And for the domain, we see that it can be equal to 3 and go up to infinity. So we have the bracket, and it starts at 3, and it goes to positive infinity. Now, you cannot include positive infinity. It's more of an idea than a number, so we don't use a bracket. We use a parentheses. And for the range, the smallest y value is 2, and that's also going up to positive infinity. So the smallest y value is 2. The biggest y value goes to infinity. And we can't enclose that. We can only, it's excluded. So there's our domain and range. All right, I'm going to stop the share so I can get back to my PowerPoint. Let's try another one. Okay, this is called a rational function because it's got a fraction in it. And I don't think we need this slider, but let's make a point called x comma f of x. Or actually, we'll call it a f of a to make a slider. So if we look at this, we can never have 0 in the denominator. So to calculate the domain, we would say x doesn't equal, we can never have 0 in the denominator. So let me stop that and let me erase that. We would say that x plus 2. Ooh, let me make lines. Where's the draw? X plus 2 cannot equal 0 because you can never have a 0 in the denominator. Now we'll take away 2 from both sides. So we'll have x doesn't equal -2. So that means our domain could be any x value except -2. So how do we denote that? We write domain and colon. So it starts out at -infinity. And it goes to -2. And we're excluding -2. And then we say in union with from -2 to infinity. Close the parentheses. All right, so that's a lot to swallow. But if we look at our x-axis, we see that x can be every single value except -2. And if I add another graph and call it x equals -2, okay, we see that's a vertical line. And what I'm going to hold that for 3 seconds so that I can make it dashed. All right, so we see that the graph going up over here gets closer to x equals -2, but never touches it. And same thing down here. If we see, we can see that it's getting closer, but whoops, but never touching it. All right, now, what are we going to do for the range? Well, do we see how the coefficient of the numerator is 3 and the coefficient of the denominator is 1? 3 over 1 is 3. That means y can never equal 3. And let's graph that. Y equals 3. Let's hold this over for 3 seconds. It's not allowing. Okay, let's try this again. Okay, I can also go to settings there. write this dashed. Done. So that's another way. So we can also see that. So y equals 3 is a horizontal line. We can see that over here, it's never going to touch it. And over here, it's never going to touch it, but it does keep getting closer and closer. We call those asymptotes. So this graph has a vertical asymptote at x equals -2, and it has a horizontal asymptote at y equals 3. So in terms of the range goes, if we look at our y values, they go down to -infinity. They go up to positive infinity, but they never equal, the y value will never equal 3. So if we're going to annotate that in terms of the range, we see that the smallest x value goes to -infinity. And we have a little pause at 3. And we can't include 3, so we use a parentheses in union with 3 to infinity. So there's the domain and the range. So if you're asked for homework, write the domain and range. This is the notation I would prefer that you use. Yeah, let's go back to our PowerPoint for a second. I have to stop the share in order to get rid of that stuff now. Let's try one more. Wow, look at this. We have an ellipse. And we see that the smallest x value occurs here at x equals -1. And the biggest x value occurs here at 9. So we would say that the domain is from -1 to 9 inclusive. So if we're going to annotate that, we see the domain goes from -1, sorry about that noise, to 9 inclusive. And if we want to find out our biggest y value will be right there, and our smallest y value will be there. So the smallest y value is -5. The biggest y value is 1. So if we're going to write the range, we would say that the range goes from, oh, I forgot my little colon there, -5 to 1 inclusive. All right, let's stop the share and then share again so we can continue with our PowerPoint slides. All right. So the domain, all the values of x that exist in the graph of a function are called the domain. And the smallest x value is -2.3. The largest x value is 2.3. So therefore the domain, we write the domain as -2.3 to 2.3 with the brackets. This is read as x equals all values from -2.3 to 2.3 inclusive. If we look at this one, we see that x has got to be greater than or equal to 3. So the way we write that is from 3 inclusive to positive infinity. We never include the infinity in the domain. So if we look at this, we did this one already. We can never have 0 in the denominator. So x plus 5 is greater than 0. X is not equal to -5. So how do we write this? From -infinity to -5 exclusive in union with -5 to infinity inclusive. So there are 2 types of domain restrictors. We can never have a negative number under the radical, and the denominator can never equal 0. So how would we describe this domain? Well, it goes from -infinity to 2 in union with 7 to 99. 2 and 7 are included in the domain, but 99 is not. Okay, the range are all the y values. So here the smallest y value is 1.233. The biggest y value is 5.125. So the range goes from 1.233 to 5.125 inclusive. Okay, let's take a look at this one. Oh, we've done this one already. All right, so we see that the domain goes from negative infinity to -5. Oh, actually, we didn't use this one, but we see that x can never equal -5 because that would cause a 0 in the denominator. So we have an asymptote at x equals -5. And make that dashed. And if we look at the ratio of the leading coefficients, it's 3/1. So y cannot equal 3. And we'll also make that dashed or dotted. All right, so for the rank domain, goes from negative infinity to -5 in union with -5 to infinity exclusive. The range goes from negative infinity to 3 exclusive, and then in union with 3 to infinity exclusive. So we'll go back to our PowerPoint. So in the rational function, the leading coefficient of the numerator is 3. So the highest degree of x are the same as the rational function. Then y can never equal the ratio of the leading coefficients, which is 3/1. Y can never equal 3. So this is how we would rate the range. All right, if we're going to calculate the range here, it's pretty easy. The smallest y value is 2 inclusive, and it goes up to infinity. So y has to be greater than or equal to 2. So it goes from 2 inclusive to infinity. And once again, we should be pausing, practicing, taking notes. Now look at this range. The smallest y, it's sinusoidal. The smallest y value is 2. The biggest y value is 4. So we say that it goes from 2 to 4 inclusive, and that's it. All right. So when you're doing the homework, look at the graphs, but prove them algebraically. So my final words of wisdom to you are, when we're doing domain, the domain restrictors are that we can't have 0 in the denominator, and we can never have a negative under the radical. And then we look at the graphs to, if we have a rational function, which looks like a fraction, the leading coefficients is what y cannot equal in terms of the range. So that's the restrictor for the range. Okay, everybody, I hope you enjoyed my little talk about range and domain. Good luck with the homework.